What I want to discuss today Bismillah, is I want to talk about indices and logarithm. Indices, the word indices and logarithm. But before I go, but if I want to do anything, the first thing I'm going to talk about is indices. Let's talk about indices. You must have heard something like indices before. I'm very sure of that. But there are some concepts in which you need to understand. So I'm going to explain them here. Let's say you have something like this. This one, which is x, we're going to call it base. This one, which is a, it has three names. The name are power, exponent, and what? Index. Those are the three names. You got it x to the power a, something like that. So now, I would now like to give you some laws, the rules that guide our distinct laws. The first one, let's say we have x to the power a multiplied by x to the power b. One thing I want you to note here is this. The moment this base are equal and you have plus and you have multiplication here, you are going to what? Add. So you are going to take one base. This one is going to be x a plus b. You are going to add them. Let me give you an example. Let's say 2 raised to power 3 multiplied by 2 raised to power 4. This one is going to be 2 raised to power. You are going to take one of these two. But I'm not counting 2 with and you are not to have 3 plus 4. So this one is going to be 2 raised to power 7, and that is your answer. Kajiko. So now, if I were to continue with the law, second law, the law 2. If you have x to the power a divided by x to the power b, this one is going to be x to the power a minus b. Let me tell you one rule here. This base and power, it is very important in indices. So you must know what base is and what power is. I will explain later, don't worry. This statement I made, I'm going to explain when I'm done with the laws. I'm going to give you some instance. So this one, let's say we have 3 raised to power 5 divided by 3 raised to power 2. This one is going to be 3 raised to power 5 minus 2. So this one will be 3 raised to power 3. And this one is going to be what? By 27 also. What I want you to understand here is that we are talking about base and power. The moment the bases are equal, these two bases are equal, it means that we are going to add their power. And if it is division, we are going to subtract it. So let's continue with the third law. The third law states that x raised to power a into bracket b is equal to x raised to power a times b. We now be x raised to power ab. Let me give you an example. So if you have 5 raised to power 2 into bracket 3, this one is going to be 5 raised to power 2 times 3 equals what? 5 raised to power what? 6. Not add, you don't add it though. Ma add here. This one will be 3 times 2, 6. That's what it means. Oh yeah. As I'm writing this one in index form or power form or exponential form, you know this one is an exponent. This one, I'm answering more exponent more call. You will let this one will be 5 times 6. This one will be 5 times 5 times 5 times 5 in 6 places. This one is going to be 5 times 5, 5 times 5, 5 times 5. So this one will be 25. Multiplied by this one will be 25. Multiplied by this one will be 25. So these two will now be 625 multiplied by this 25. So you know times it. I cannot be doing that one. Another law is this. You have x raised to the power x raised to the power minus a. This one is going to be 1 over x. Whenever you see inverse of an x of any number, it's going to be 1 over that thing. Let's say you have 3 raised to the power minus 2. This one is going to be 1 over. No, don't let me do this first. So let's say this one is raised to power 1. 1. This one is going to be 1 over 3. That's what it means. Like you said, x is power minus 1 is equal to x to power 1 over x. 1 over x. 1 over x. Just like that. Now, let's now say we have x is power 1. Let's say we have 2 raised to power minus 3. This one is going to be 2 raised to power 2. 2 raised to power 3 into bracket minus 1. That's what it means. So this one will now be 1 over 2 raised to power 3, which is equal to 1 over 8. 2 raised to power 3 will be 2 times 3 times 3. That's 2 times 2, so it will be 8. This one will be 4, this one will be 2. 2 times 4 is 8. That's why it is 8. More or less like you have x raised to power minus 2 will now be 1 over x squared. Y raised to power minus 2 will now equal to 1 over y squared. Or you have x power minus 3 will be 1 over y cube. Show you why, and I hope you understand this. That's the rule. Another rule is this. Number 5 also. If you have x power 1 over a, it will be equals to square root of x in a, root of x in a. So now let's give an instance. Let's say you have 4 raised to power 1 over 2. This one is going to be root of what? 4. So this one will be 2. Or you have plus or minus 2. When you get to complex number, you understand the meaning of this plus or minus 2. Complex number, I say complex number. You understand the meaning of this plus or minus 2. Or you have, let's say, next power 1 over, I don't want to use 9. Let me use 27 raised to power minus 3. 1 over 3. This one will be cube root of 27. So this one will be 3. And I hope you understand the meaning of this cube root. Okay. So now, let's say we have the 61. X raised to power a over b. This one is going to be b root of what? X or raised to power a. Let's say we have 2 raised to power 1 over, no, not 1. This one is, let's say 4 raised to power 3 over 2. This one will be square root of 4 or raised to power what? 3. Square root of 4 is what? 2 raised to power 3 will now be 8. That's the answer. Square root of 4 is going to be 2. Put 3 there. So this one will now be 2 times 2 times 2. That's what it means. Show ye the next one, or 7. Actually, I don't know. Okay, the 7th law. Law 7. Number 7. Let's say we have x power 0 equals to 1. Anything x power 0 is equal to 1. Anything x power 0 in the law of this is 1. Now, I want to now tell you equal base. I want to show you the. Let's say you have x is to power 3 equals to x is to power y. You now said find y. So yes, since base are equal, in that base is equal, x is power 3 equals to x, y is power 3. This one comes with this, y equals to 3. That's the answer. Equal base, number 1. Another one is this. Let's say you have 2 raised to power x equals to 2 raised to power 5. Since they are equal, since this one is equal to this, x equals to what? 5. That's the rule. This rule, while Logan, you must be applying it and you must know it. Equal base. Now, equal power or exponent. You know I told you, or index. I told you we have 3 names for our power. We have two names of power, index, and exponent. Those are the three. Let's say you have 3 raised to the power 5 equals to x raised to the power 5. The moment the powers are equal, the base are equal. When the power is equal, the base is equal to. So it means x equals to 3. Another example is when we have 4 raised to the power 6 equals to 1 raised to the power 6. 4 equals to y. Now, let me give you an explicit example on this. Let's say you have 81 raised to the power 3 over 4. So this one is going to be 4th root of 81 all raised to the power 3. 4th root of 81 is going to be 3 times 3 times 3 times 3 in 81 you get. So this one will be 3. So 4th root of 81 will be 3. Will now be 3 all raised to the power 3. 4th root of 81, like you know, this one is 3 times 3 9, 3 times 3 9, 81. I only showed you. Mark over you, more can feel any o. Show more got him on so by show ye by ye o. Master went to go to show for a buy you, I'm a combine o. Show ye by ye o. Now this one will not be raised by 3, will not be what? 27. That's the answer. Another one is this. Number 2, the service is simplified 16 raised by minus 5 over 4. This one, the first thing you must know here is this 16 raised by 5 over 4 raised by minus 1. So wakoshili ile okoje 1 over, so raised by minus 1 you get 1 over 16 all raised by 5 over 4. This rule rule number 4 only this rule, anything by minus something, this by minus 1 or something, 1 over can come on that low. And I hope you understand what I'm saying. So now this one will now be 1 over 4th root of 16 all raised by 5. 4th root of 16 you might get 16 might get 2 times 2 times 2 times 2 in 4th root there. So my mutual you combine. So you get 1 over 2 raised by what? 5. So 2 raised by 5 is what? 2 times 2 times 2 times 2 times 2. 2 in 5 places. So you get 32. 1 over 32. Answer here. And I hope I'm making sense. Like I'm really making sense. So the next one, example 3, which is simplified 5 raised by 1 over 4 into bracket 1 over 2. So when you have this bracket, you are just going to have the base 5 raised by 1 times 1 over 4 times 2, 8. So this one will now be 8 root of what? 8 root of what? 5. So that's the answer. Or you have it like this. 5 raised by minus 8. Is this so? No, this one is not correct. So that's the answer. Now the next one, we have 81, 8 raised by 7 over 3, not 81. So this one will be cube root of 8, all raised by 7. Cube root of 8 is 2 times 2 times 2, so it will be 2. This one, cube root of 8 will be 2 times 2 times 2. So you get 8 by n. So this one will now be 2 raised by 7. And 2 raised by 7 is what? 128. 2 raised by 7 will be 2 times 2 times 2 times 2 in 7 places. And I hope you understand what I'm saying. You're going to multiply it. I don't think it is power for me to be explaining 2 times 2 times 2 times 2. You must know that. Number 5. You have 36 all raised by minus 3 over 2. So this minus 4 is called 1 over 36 all raised by 3 over 2. So now let's do this. Doing this one will be going to be square root of 36, or you can say that now. All raised by 3. 1 over something, or you can say something like that. This one will now be 1 over square root of 36 is going to be 6 times 6 times 6, all raised by 3. So this one will now be 1 all over 6 times 6 times 6. So this one will be 36. 36 times 6 will now be what? I don't know. So you must find the answer for yourself. 1 over something. Tell me what the answer is. This one is going to be 36 over 6 multiplied by 6. So this one is going to be 36 multiplied by 6. So 6 times 6 is going to be what? 6 times 6 is going to be 36. 6. Give me that word 3. So 6 times 6 is going to be 18 plus 8, this 9. So and I hope you understand this 1 over this. I hope you understand it. So the next one is going to be, they said express in positive index. Express in positive, positive is this index. Indices. Okay, sorry. So this one, they said we have x bar minus 2, y raised to power 3, z raised to power 4 all over 6 multiplied by 9 over x power 3, y raised to power minus 2, z raised to power 4. So now, when you want to do this type of question, this is multiplication, and you have x raised to power minus something here. Okay, báwo la ṣe? Kò le. Just look at it like this. There's a solution. This one is going to be, this one is going to be 1 over s square. 1 over s square multiplied by y cube, z raised to power 4. Multiplied by, this one normally is 1 over 6. 1 over 6. Now this multiplication, multiplied by 9 over, this one is going to be x raised to power 3 multiplied by, this one is 1 over y square multiplied by z raised to power 4. And I hope you understand what I'm saying. So this one will now be 1 times y cube, z raised to power 4 multiplied by 1 all over 6s square. S square times 6 multiplied by 9 multiplied by over, this one will be over x raised to power 3. This one is going to be 1 over y square. 1 over y square. So when you change the base, this one will be y square over 1. So it will be multiplied by y square multiplied by 1 multiplied by z raised to power 4. So that's how it's going to be solved. So this one comes with this, like this. Here you get, we have s square, y square, s square. So we now have 9 and 6. 3 here, 2. 3 here, 3. You have 3 times y square. 3y square multiplied by y. 3y cube multiplied by y square over 2x square s cubed. So this one will now be equals to, this one will now be equals to 3y. This one is multiplication, like multiplication. So you now use the first law of indices. You now be y raised to power 3 plus 2 over 2 raised to power x 3 plus 2. So this one will now be equals to 3 over 2 y raised to power 5 x raised to power 5, and that is the answer. And I really hope you understand what I'm saying. Oye dada. The next one, they said that we show that this one, root of x minus root of a is equals to x minus a over root of x plus root of a. You see this type of question, when you want to show something, one thing you must notice here is that how are this one and this one are related. One thing I want you to understand is that you should know that this one, when them talk say make you show, this one that they say you should show is the opposite of this, just by putting minus, multiplying by minus. That's what kind of minus in a plus a minus in token that a lot on. It means that they rationalize it. So solution. So from left hand side means this in the root x minus root a. Mark up to our from clinical. I'm only showing you where you can write it for explanation, but you are not doing theory. You are doing objective, so that's why. But you can do theory in the test. That's why I'm showing you something related to like proving. So now when you want to rationalize this, we have root x minus root a from the left hand side. They say equals to this, but I want to prove this right. Okay, this right hand side. I want to prove it. Where this left hand side, this left, so left hand side is equal to this right hand side. I want to prove it for you. So what I want to do is that this one multiply by, if I rationalize it, root x plus root A all over root okay, let's say this one is over 1 multiplied by root S plus root A. One thing I want you to understand here is this. You know, this one is the question that we are given. I only multiply it by this one and this. I can cancel, but ele cancel ele kò di 1. You can get 1 times this over this. So ó tó padà fún mi lélẹ̀ padà. Ó tó padà fún mi lélẹ̀ padà. But I need it. That's why two you can cancel it. I want to use it for something. So that's why I don't want to cancel it. I know you understand what I'm saying. So now this one will now be x times x with x times root x in sod. It's going to be root s square. So we now have x. Wow. Àti parí alákọ̀ọ́bà. Ẹlẹ́ẹ̀kejì ó jẹ́ x times minus ó jẹ́ minus root a root x times root a will now be minus root ax. Tó máa jẹ́ ti ẹnìyẹn. Ẹlẹ́ẹ̀kẹta náà ó jẹ́ root a, this one root a times root x, root a times root x ó jẹ́ plus root ax. And the last one ó jẹ́ root a times root a minus root a times root a, ele and ele, this one and this will now be root minus root a square will now be a, because this square will cancel this square root. Likewise this square will cancel this square root. So now this one will now be equals to a here. This one will be equal to a here. So now if I want to do this, continuing this, so now doing this, I will now have root of x minus root of a multiplied by root of x plus root of a over 1 all over root of x plus root of a. You know I told you that I can cancel these two. These two, I can do like this and this. But I don't want to do it because mo fẹ́ lò fún ẹ̀kan ló jẹ́ kí n lò bẹ́ẹ̀, ló jẹ́ kí n fi lẹ̀ báyẹn. So mi ò ní cancel ẹ̀, màá ní ìdẹ. So yóò máa jẹ́, ṣọ̀kan mo ti multiply eléyìí, ó máa multiply eléyìí, ó máa multiply eléyìí, ó máa multiply eléyìí náà máa multiply eléyìí. And I hope you understand that. So now, this one will be equals to x, ọkọ̀ mo ti ṣe sílẹ̀, x minus root ax plus root ax plus a, no minus a ní ó jẹ́ minus a lè jẹ́ minus a. So over this one times 1 root x plus root a. So this one will now be equals to x minus root ax minus root ax minus a all over root x plus root a. So this one cancel this, plus and minus. So over x minus a over root x plus root a. Abina root a. So, and I think this left right hand side ought to approved like that. So it's my RHS right hand side proved. It must make sense here. This is the right hand side. This is the right hand side. This one. With x minus a over with x plus root a. X minus a over with x plus root a. And that's the answer. And I hope you understand this. If you have any problem relating to all these questions, all these issues, all this wala, please let me know. Because I'm still going to do more questions for you. So you get like that. So, subhanakallahumma wa bihamdika, la ilaha illa anta astaghfiruka.